One. Okay, so we've learned the rules. Now here we go. The derivative with respect to x of natural log of x is 1 over x, 1 over x, 1 over x, 1 over x. The derivative of the absolute value, the derivative of the natural log of the absolute value of x is still 1 over x, not 1 over the absolute value of x, 1 over x. Okay. I've seen a question before in the AP exam, multiple choice. It was just that. It was just what's the derivative of the natural log of the absolute value of x? And of course, that was an answer choice, but this was an answer choice, like this was an answer choice, all kinds of things. So if you know what it is, you're good. And then, of course, the chain rule is always in the house. The natural log of u would be 1 over u times u prime. That's the chain rule. And of course, you can even add the other one here. That's a combination of the derivative with respect to x of the natural log of the absolute value of u. It'd be the same, 1 over u times u prime. So even if it's around like a function of x, the absolute values go away. Okay, so test tomorrow, just real quickly, test tomorrow. Because we've really covered everything, and it's 2.1 through 2.10 essentially. Yeah. Part multiple choice, part free response. All right, so we're going to modify our mantra now. One of our mantras: simplify early and often. Simplify early and often. Now we're going to add to the end of that comma, especially when you have logs, because logs are designed to make molehills out of mountains. They cut everything down to size. So let's see what we do here. We're trying to find the derivative of each of the following. So if h of x is cosine of ln of x, is there anything we can do? Any simplifying? We have cosine of natural log of x. I don't think there's any simplifying we could do, but there are two layers, so we'll have two links in the chain. So the left side becomes h prime of x, and the right side, here we go. The derivative of cosine of blob is negative sine of the blob. Okay, and I'll do it like that. And then times the derivative of the blob, 1 over x, right? And that's it. We're done. So if we did clean that up, maybe negative sine of ln of x all over x, something like that. And be careful too, that negative could actually be, it could be sitting out front like that, kind of sneaky like on the same level as division bar, but I tend to like to put it in the top. Okay. So questions on that one? That was noun format, right? Noun format. So is it okay to put ddx, the verb, in front of h prime like that? Is that okay? Yeah, that's okay. Is it required? No, not in an explicit problem. All right, this one. Ooh, y equals the natural log of 1 plus the natural log of x. Simplify early and often. Does anything need to be rewritten? I don't think so. I mean, if you're going to do anything, maybe you add parentheses around that, but that's inside, it's just plain old x, so it doesn't really require the chain rule. But there is one chain rule, right? It's natural log of blob. So the left side becomes y prime or dy dx, either one, and working from the outside in, right? That's how we do it. So the outside layer is the blue layer. We get the derivative of the natural log of blob is 1 over the blob. Okay, and then times the derivative of the blob, parentheses, what's the derivative of the first term in the blob? 0, which we don't even really have to write, plus 1 over x. And that's it. Then it's just a matter of simplifying. I'll go with green here. So dy dx is 1 over, and because really this is just a factor of 1 over x, we can multiply it in the bottom. I probably would not distribute it unless I had to. We tend to like things factored, so I'll just put that factor of x in the bottom in front of there. And there it is. Pretty nifty. Nifty, nifty indeed. All right, letter C. We got f of u is the natural log of the square root of 3u plus 2 over 3u minus 2. F of u, indeed, f of u. I'm not going to do that one. Right. The independent variable is u. The dependent variable is f. Simplify early and often, especially when you had logs. Well, so far we haven't really been able to simplify anything, right? Like we couldn't distribute the log up there. That doesn't make any sense. There's really nothing to do. But in this case, I think there is something to do, right? Because if you have the log of a product, it becomes the sum of the logs. If you have the log of a quotient, it becomes the difference of the logs. And if you have a log raised to a power, it becomes multiplication, the power times the log. So let's go ahead and rewrite this before we take the derivative. F of u is the natural log, first of all, of that entire quantity to the what power? 1/2. Now, boy, howdy, can I do something now? Yeah, I could bring the 1/2 out front, right? And this is still f of u. So that's going to be 1/2 times the natural log of 3u plus 2 over 3u minus 2. Now, if that were the only thing that I were to do, that would be worth it because I don't have this ugly chain rule anymore, right? When something's raised to the 1/2 power, it's like 1/2 blob to the negative 1/2. That creates like a radical in the denominator. But now the 1/2 that caused all that trouble, he's just a constant multiple. He's going along for the ride. Wow. But is there anything else we could do? Yeah, I now have a quotient of 2 logs. That turns into the difference of 2 logs. Now, at this point, you do want to be a little bit more mindful of the 1/2 out front. No, because I didn't take the derivative. Right. It has the appearance of the power rule, right? 1/2 blob to the negative 1/2. But I didn't multiply and then subtract. All I did was I used this property here. I brought the R out front. Yeah. So yeah, it does look like the power rule. That is kind of a nice observation. And that's why it's important to still call it what? F of u. All right. Now the 1/2, I'm going to leave it out front and I'm going to put a beefy bracket. This is where some people make a mistake. The log of a quotient is the difference of the logs. So this becomes the natural log of 3u plus 2 minus, the denominator gets the minus sign, 3u minus 2. Okay. So the 1/2, if you didn't want to put the brackets or another set of parentheses up front, it would have to be distributed to both terms. Yes. So as long as you account for it correctly, you're good. Now that's good because that gets rid of the Hody-High rule and it just turns it into 2 separate terms. Now at this point, you can distribute the 1/2 or you can leave it out front. Can we do some more? Can I distribute the natural log inside of its own argument like that? No, that does not work. You cannot do that. So that's about as far as we can get unless we distribute the 1/2. Boy, that's going to be easier. Now, finally, I'm ready for f prime of u. So f prime of u is equal to the 1/2 is out front. He just goes along for the ride. So it's 1/2 times the derivative of what's inside. Well, the first term is natural log of blob. That's 1 over the blob times the chain rule, the derivative of the blob with respect to u, which is 3. Yeah. Now we move on to the next piece. Natural log of blob again, that's 1 over the blob times the derivative of the blob itself with respect to u, which is another 3. And that's it. Wow, that's the derivative. That is so cool. And again, if you felt more comfortable distributing the 1/2, then that's fine. It would still be a factor in each term. But you can have a constant multiple times the things that have a lot of variables, and he's just out front hanging around. He goes along for the ride. All right, so all we would have to do, I guess, is clean up. I guess we have the option of either distributing the 1/2 or even factoring out another 3. I would probably just factor out the 3 because as you're going to learn later, what we're doing is setting these equal to 0, and we want them to be factored as much as possible. And maybe I'll kind of get rid of the brackets and just go back to a parenthesis. It's less urgent. Maybe it creates less of a panic, right? But there it is. If you wanted to get a common denominator, you could do your crisscross applesauce there. But that's the derivative. We're done. That's fantastic. Fantastic. Thank you, logs. Thank you very much. Okay. Now let's take a look at what this might have looked like had we not utilized the power of logs. I'm going to add a sheet of paper. Okay, and I'm going to go to it right below it, and I'm going to just paste it, and I'm going to say, okay, what if, right? What if we don't realize that we should expand it first? Well, I would definitely have to still get rid of the radical and write it like this. Okay, but look what would happen. Now I'm going to take the derivative. F prime of u is going to be, let's see, if you want, put another set of brackets here, right? It's not the chain rule right away. It's not 1/2 blob. You walk up to it and it's like, what's up, natural log of blob? So that's the rule out of the box. That would be 1 over the blob, which I'll put it back in radical format. 1 over the blob. Boy, that right there is already gross. Yeah. We have a complex fraction and the denominator is a radical. Ugh. 1 over the blob times the derivative of the blob. Well, now the blob is, you know, this part inside. So that's going to now be the 1/2 times 3u plus 2 over 3u minus 2 to the negative 1/2, right? 1/2 blob to the negative 1/2 times the derivative of the next layer, which is the quotient. So now it's ho d high, ho d high minus high d ho all over ho ho. There's the derivative. Yucky, yucky, gross, gross. Yeah. Now imagine trying to simplify all that. It wouldn't be fun, right? It could be done.
Wait, but if it's a free response, can we duplicate that?
Maybe, yeah. It depends. On a free response, sometimes it might say show that dy dx or du dx equals this. And then you have to get there. You can't just like have this line and then the last line that they gave you. You have to actually show the work.
It works.
Okay. All right. So anyway, let's come back up here and just marvel at the simplicity of this answer. Not only does the final answer look simpler, looks easier, but the process of getting there was less risky, right? The fewer steps you can have or the cleaner steps you can have, the less likely you make a careless mistake. And that was all brought to you because there was a log in front. Okay. So simplify early and often, comma, especially when you have logs, and then learn to play with the logs at the end of your answer, right? So for example, we were talking the other day, if you have something like 6 natural log of 3 as your final answer, and it's a multiple choice question, that may or may not be an answer choice. And you may be like, College Board, hi, yeah, you got a typo, right? And they're like, no, you are wrongo. So let's see what we could do. Let's see what we could do. We could call the 6 in front a 2 times a 3. That's easy. And now using that property, I could bring any one of those up. If I want to bring the, let's say I want to bring the 3 up, leave the 2 down there. That becomes 2 times the natural log of 3 cubed, bless you. 3 to the third is 3 times 3 times 3, which is 27. So 6 natural log of 3 is the same as 2 natural log of 27. Yeah, it is. Okay. What if you wrote it as 2 times 3 natural log of 3, but now instead you brought the 2 up at the top and left the 3 in front? That'd be 3 times natural log of 3 to the second power, which is 9. 6 natural log of 3 and 3 natural log of 9 and 2 natural log of 27 are the same. Yes, they are. Right. What if you have the natural log of 1/8? Okay, that would be the same as the natural log of 8 to the negative first, wouldn't it? Yeah, because 8 to the negative first is 1/8. That's the same as negative natural log of 8, right? Yeah. But wait, there's more. 8 is the same as 2 cubed. So now bring the 3 up front. That's negative 3 natural log of 2. So if you have an answer of the natural log of 1/8, it may not be a multiple choice answer. You may have to say, oh, that's the same as negative 3 natural log of 2. Go me.
Stuff like this still be on the test.
Maybe.
No, that-
Yeah. If there's a multiple choice question with logs in it, you need to learn to get to the right answer because College Board will do it. I'll do it. I know of like 2 other people in the world that'll do it, right? Miss Skurhawk and Einstein. Okay. So anyway, learn to play with logs. Okay. Now, question. Are we always going to see logs that are natural base E, natural logs? No, the common log is actually more common. So how do we take the derivative if it's not base E? Well, I'm going to show you how. You ready? Ready? Here we go. This is called the change of base formula. You've seen it before. It allows you to change from one base to another base. So if you have in general log base B of X, where the base is any legal base, right? Between 0 and 1 decay, greater than 1 growth. That's the same as log, choose another base like A. I'm going to choose a random base A. That's the same as log base A over of X over log base A of the old base. Okay. Now, of course, naturally, like you said, most of the time we're probably going to choose base E. So that would be the natural log of X over the natural log of the base. Or if you're in science class, you choose base 10, that's going to be log of the argument over log of the base. So notice it's really the same idea. If you look at the log that I gave you, you know, the subscript is nice because it's actually written lower. You got X and B, and notice the X is over the B. So that's how it's going to be in all of your ratios. Okay, X over B, X over B, X over B. All you got to do is pick another base, right? So the natural log of X over the natural log of B, that's base E. Log of X over log of B, that's base 10, or 7, right? Log base 7 of X over log base 7 of B, or 1/4, right? Log base of 4th of X over log base of 4th of B. Got it? So if I want to find the derivative for, in general, log base B of X, I only know how to take the derivative of the natural log of X, right? So let's go ahead and change that. So Y equals log base B of X by the change of base formula. That's equal to the natural log of X divided by the natural log of B. Everyone okay with that? Your TI-84s too, this is how you evaluate logs of different bases very quickly. If I ask you like, what's log base 4 of 7, you just type it in, natural log of 7 divided by natural log of 4. Okay. So that works. Now, because the base is a number, the natural log of the base is a number. Yes? Okay. So I can rewrite this now as Y equals 1 over the natural log of B times the natural log of X. And so 1 over the natural log of B is also a number. Would what be the negative one? Well, I'm not going to bring it to the top. I'm just going to leave it. You can call the whole thing to the negative first power. I just kicked the natural log of X out of the numerator, right? If you multiply straight across, it's still equivalent. We like to bring our numbers out front, and that's what I have. I have a constant multiple out front. That's a constant multiple. It goes along for the ride. Yes, yes. Okay, so let's go to a new column. Let's take the derivative of both sides. The derivative of the left side is dy dx. The derivative of the right side is, well, constant multiples go along for the ride. So that's 1 over the natural log of B times, What's the derivative of the natural log of x? 1 over x. And we're done. Wow. So if I simplify that, write that all together, that's 1 over x times the natural log of b. Now remember, we usually again write our coefficients in front, but I don't want to write it as 1 over the natural log of b times x, because that looks like the natural log of bx. And I would have to put one of them in parentheses. Okay. So this is the better version. So that works for all of them. So here's the general rule. The derivative with respect to x of log base b of x is, watch, just like the natural log of x becomes 1 over x, so does every log become 1 over x. We just have to remember to divide by the natural log of the base, which is the same as multiplying by the natural log of base in the denominator. Okay. Now, does it work for base e? Sure, right? The derivative with respect to x of the natural log of x is really the derivative with respect to x of log base e of x. So by this rule, it would be 1 over x and then divide by the natural log of the base, which is e. But what is the natural log of e? 1. So the natural log, which is the natural base, is the only log that is just 1 over the argument. Just like the derivative of e to the x is the only one that's e to the x. Now look at the symmetry here. The derivative with respect to x of b to the x exponential was itself b to the x and then times the natural log of the base. For exponentials, we multiply by the log of the base. For logs, we do what? Divide by the log of the base. How are multiplication and division related? Inverses. How are exponentials and logs related? Inverses. Yeah. Now, if you ever forget which one goes where, oh, yeah. If you want, you could say it's 1 over the natural log of e to the x power, or the base. Yeah. But typically we don't do that, right? But you can. You can bring this x back up. So what I'm trying to get you to remember is e to the x is its own derivative. If it's not base e, multiply by the natural log of the base. The derivative of the natural log of x is 1 divided by x. But if it's not base e, we divide by the natural log of the base. Okay. Symmetry. Maybe up through there. Maybe it'll be real straightforward. Okay. We'll practice with that on Friday if we don't go over the test. Okay. Your worksheet is not due. Your worksheet is not due for logs for 2.10. We did not finish.